Hey, hi guys. So, in the previous session, we have seen collection and the child interfaces of the collection interface. So, we have seen list interface, queue interface, set interface, DQ interface, and sorted set interface. So, why we use these interfaces? So, we have seen in the previous session. So, today we will understand the methods of collection. Whatever the methods are available in collection interface, those methods are available in these child interfaces as well. List, queue, set. So same method, whatever the methods are available under this collection interface, same method will be available under these child interfaces as well. List, queue, set, DQ, and sorted set. But apart from those methods, list, queue, set, DQ, and sorted set, they have their own methods as well, right? So today we will understand the methods of collection and whatever the methods are available under the list. So we are going to see methods of collection and list interface, right? So let me recap. Collection is an interface. It is a base interface. As you know, in the previous sessions, I have explained you. Collection is a base interface, and this list, queue, set, DQ, and sorted set is a child interface of this collection interface. List interface can implement these classes: list, array list, linked list, vector, and stack. So this vector and stack, these classes are legacy classes, right? So list interface can implement these classes: array list, linked list, and vector, right? And queue interface can implement to priority queue, and DQ interface can implement to array DQ as well as linked list. And set interface can implement to this hash set, linked hash set, and sorted set can implement to this tree set. And yesterday we have seen list we use to maintain the insertion order, and it also maintains a duplicate elements. Queue maintains FIFO, first in first out. DQ maintains LIFO, last in first out. Set doesn't maintain any order, right? And it doesn't contain any duplicate element as well. Duplicate elements are not allowed in set, right? And the sorted set, so it maintains ascending order, right? So we have seen yesterday, but I just revised today as well so that it will be remembered to you, right? Now we are moving into the methods. Collection method. Methods. So what all methods are available under this collection? So first we have a add method. Add object. We will add object, right? This is a object. So how we can add? Let's suppose that we have this collection, right? This we have this collection. Here we have a number of object, right? But if I'm asking you to add any object, right? Then how we can add? Add basically it is used to insert an element in this collection. This is a collection, right? Company 2 is a collection where we have a set of objects, or we can say elements. So this add basically it is used to insert the element, or we can say object. So if you want to insert any object, then here you can add it, right? It will add, right? Now we will move into the second method. Second method we have add all. Add all method. Here we use collection. So in add all we use collection of object. So assume it, this is one collection, right? This is one collection. Now what we are saying, add all this. Now I want to add this company one collection into this company two. So what we will do, here we have a collection of object. So if we want to add collection of object into this another collection, then we can use this add all and then this collection name means company one. So instead of this collection C, you can add the name of this company one, right? So if you want to add collection of object into another collection, then you can use this method, add all method, right? Now we have a remove method. Third method we have a remove. So basically this remove method will remove the object. So any specific object which you want to remove from this collection, then you can give the index. Now fourth method we have a remove all. Remove all. So again remove all, what it will do? It will remove the collection. Group of object it will remove. So wherever you can see all, right, it means group of object we are removing, or here if you see add all, it means we are adding group of object. So if you want to remove group of object, then we can use this remove all method, right? Now we are moving into the fifth method. So fifth method we have a retain all. Retain all. So retain all means here we have a collection C. So here what it will do, except this collection C, right? Except this group of object, it will remove remaining the object. Remaining object will be removed. Suppose that this group of object has been added in this company 2 collection, right? So what it will do, that group of object will be remaining, and apart from that group of object, these remaining object will be removed. That means that is the retain all method. This retain all method, except this collection object, it will remove remaining elements which are available here, right? So so far we have seen 5 methods, right? Now we have a many more. Sixth one, if you want to clear all the elements, all the object, if you want to remove from the collection, then you can use clear method. Clear method. Then what it will do? It will clear all objects, all elements. Now 7. If you want to check whether this collection is empty or not, right? So if you want to check whether the collection is empty or not, then we can use this method is empty. So it will return either true or false. If is there any element, then it will return false, and if there is no any element, then it will return true, right? Now we have a one more method, that is if you want to check the size of this collection, means how many objects are available in this collection, then we can use the method size, right? So these are the methods, right? So these are the methods. Now we have another method that is contains object. So contain, what it will do, suppose that here we have a so many name, right? So many objects are there. So what I want to check like suppose that employee 4, right? So what I will do, I will check whether this employee 4 is available under this collection or not. Then we can use this contains, means we can check whether employee 4 contains this collection or not. Then we can use this method, right? It will check whether this collection is represent to this element, this object or not. Now we have another method, that is contains all. Contains all. So wherever all will come, that means it is representing to collection, group of object, right? So contains all means it will check, it will check whether this group of object is available under this company or not. Means it will represent group of element. So it will check whether this collection, whether this company to collection is containing this group of object or not. Then we can use this contain all method. We have one more method, that is if we want to convert this, if we want to convert this object into array, then we can use to array method. And here we can suppose that this is a company to, right? Company to is a uh, we can assume it this is a collection, right? So here we can write collection. So whatever the element is available under this collection, it will convert into array, right? And it will return object array, right? So these are the common methods which are available in list, set and queue as well. These are the methods of collection. These are the methods of collection, right? So since collection is a base interface of list, set and queue, so it means these methods will be applicable for this list, set and queue. It means these methods will be available in, it will be available in child interfaces as well, right? So whatever the methods we have seen under this collection interface, those methods will be available under this list, queue, set, dequeue and sorted set as well, right? So these are the common methods, right? So far we have seen the collection methods, right? Now we are moving into the list. But under this list, set, queue and dequeue sorted set, so under that child interfaces, apart from these methods, they have their own methods as well, right? So now we are moving into list interface methods. So whatever the methods so far we have seen, these methods will be available under this list interface. But before moving into this, we can recap again what is list, why we are using list interface. So again, list interface we are using to maintain, to store the data in a insertion order. And second thing, list interface will allow to store the duplicate element. So these are the two main benefit. That is the reason we are using list interface, right? So now we will see the methods of list interface. So let me explain you one more thing. Let me create one diagram so that it will be little bit more clear. Assume this is a array, right? Where we are going to store some value. Right? So here, suppose that I am storing some number, let's say 2, 4, 8, again 2, 6, 8, 9, and 11. And assume this is a list. And we have some index as well. Index will start from 0, 1, 2, 3, 4, 5, 6, 7. So in the list, here we have a add. So same we have seen the add method in collection as well, right? But in the interface as well, in the list interface as well, we have a add method. In the collection we have a add method, but still we have a add method in list interface as well. But here how we are using? In the collection we were using only object, right? But here we will use index. Index comma object. So why we are using here index? Because this is a first method, right? This is a first method. So if we want to add any value, right? Then it means, suppose that we have some duplicate number, right? So how we can specify where we are going to store? So that is the reason every element is representing to index number here. Every element, right, is representing to this index number. So if duplicate number are there, then how we can differentiate? So we can differentiate with the index number only, right? Because here you can see that we have a duplicate number, right? Since list interface allowed to store the duplicate element, right? So how we can differentiate? With the help of this index value. This is the index value, right? So that is the reason we are using this index value, and here in the add method as well we are using index. So if we want to add any value, any element, then we can use the index number. So suppose that if you want to add any value at the index of 7, then you can use here 7, and here you can add any number, whatever the number you want to store it, right? So that is the reason we are using here index. But in collection we were not using this index. We were using only add, right? Because there we are not using index. But in the list we are using index, because here it contains duplicate element as well, right? Now second method we have a add all. So same, in add all method as well we will use index, and then we can use here collection, right? And third method we have, that is remove method. So in the remove, again we will give only index, but in collection we were giving the object name, but here we are not going to give the object name. Here we will give the index number, and with the help of this index number it will remove the element. Now we have a fourth method, that is get. Get method, collection doesn't have the get method, but this list interface has the get method. Index. So if you want to get any number for particular index, then you can give the index number, then it will return the value, right? So this get method will return the value of that particular index, right? It will return the element, or you can say object, right? Now fifth one, we have a method, that is set method. So again, in the set, we will have to provide index, comma, object. Object means element. You can say object or element, right? So set method, what it will do, it will replace the existing data. Suppose that I want to replace the value of this at index 3, right? So what I will do, I will give the index here 3, and here whatever the number I want to provide instead of 2, we can provide the number here. So whatever the number you will write here, whatever the element you will write here, it will replace with this existing one. So set method will replace the existing data or element, we can say. So we have only these methods in list interface apart from this collection interface. So far we have these methods in list interface. So list can use these methods, these collection methods, as well as list can use their own method as well, right? So today we have seen the methods of collection interface, and we have seen the methods of this list interface. In tomorrow's session, we will understand these classes, this array list, linked list, vector, stack. So these classes we will understand in next session. And once we will completed this list interface, right? List interface and these classes of list interface, once we will complete it, then we will move into this queue and set and dequeue and sorted set, right? So I hope you understood. Still, if you have any question, then you can ask me in the comment. I will try to reply you. Thank you, guys.